So, hello and welcome to the DV Digest. My name is Brody, and this is your monthly digest of insight from design verification leaders. Now, today we have a very special guest. We have Tudor Brown. Tudor was one of the co-founders of ARM and helped build it into the juggernaut that it is today. Following that, he sat on the board of a number of highly prestigious companies, including Marvel Semiconductor, Lenovo, and SMIC. So in this conversation, we talk about a few different things. We talk about what it takes to build a successful business. We talk about how the UK semiconductor market might change and fare in a world of global rising trade tensions. And we also talk about why Tudor thinks that verification is in fact way more important than design. We have a few technical issues towards the end, which means Tudor's video unfortunately cuts out. So apologies for that. But other than that, I really hope you enjoy. So, Tudor, welcome to the podcast. I really appreciate you coming on.
Thank you.
I think starting off, we were both at the ChipStart event back in March, and you made the point that ARM was successful not necessarily because of the product, but because of the business model. Could you talk a bit more about that and tell us why you think that?
Sure. So the point I was making then, and it's a point I've made many times, when somebody starts a company, they have a product almost by definition, and they think that product is unique and special and that's going to sell itself. And sometimes, a very good product can sell itself, but more often than not, it's not so much the actual product that's the key thing. It's the way you sell it and the business that surrounds it. Whether that's the business model or the way you go to market or whatever, those things are much more important very often than the actual product. And so obviously my ideas were formed from my days in ARM, where the ARM microprocessor back in the early 90s, it was a great little product, but it wasn't unique. It was a small risk microprocessor, but there were other ones around. There were competitors of that exact technology. But the way we went to market by licensing and not trying to manufacture silicon, that's what made ARM unique and ultimately very successful. So that's my point, that it's not just about the product itself, it's about how you sell it.
Yeah, okay. And how would founders go about kind of testing their business model to see if it's really fit for purpose? How would you advise someone and sort of test whether their business model is good?
Yeah, well, there's no silver bullet here. There's no one way of doing it. You've got to take advice. You've got to talk to people. It can be difficult if you're kind of trying to go under the radar, but ultimately you need to break out and you need to get advice from people who have done similar things before. Don't be afraid to ask questions. But the other thing I would say is business models evolve, right? So what you might think of as the first way of going to market, as you get into that, you may find a different nuance or a different trajectory. And I'm always believed, we've been a big believer in what I would call sort of perturbation theory, trial and error. You try something a little bit, see if it works. If it does, you do a bit more of it. If it doesn't work, you backtrack and try something different. And so, yes, you've got to have your grand ideas. You've got to have your fundamental way you think you're going to go about it, but be open to change. That's I think, the most important thing.
Yeah, okay. I mean, feel free to not answer this one if you don't want to. But what do you think about ARM's recent move to start competing with their customers? What do you think about that?
I think it's fair to say there are quite a lot of people from, if you like, the old ARM, the traditional ARM, who think ARM is going the wrong way and breaking the business model, changing what they did for 30 years, and competing with their customers and all those things that we said we'd never do. On the other hand, if I stand back from it, 30 years later, maybe it is time for the business model to change. And maybe the world is different now. The world was different when we started out in the 1990s. We were just getting into the beginning of SoCs and having small components that were integrated into other functions on a chip. Today, we're moving into a even more complex world where actually a lot of these systems are put together with chiplets and 3D packaging and multi-dimensional things. And so, yes, it's easy for old people like me to say, oh, ARM's got it all wrong and is breaking what we did so successfully for so long. Actually, a bit like what I was saying earlier, you've got to change. You've got to change with the times. And so I'm interested to see where it leads. Yes, it's going to upset some people, but it might mean the ARM architecture or parts of the ARM architecture are more suitable for the current times going forwards,
Cool. You also mentioned in the ChipStart event last March the importance of getting the right people on board, and you made a comment that you would often test engineers, so making them kind of turn up to interviews or at awkward times or awkward places, which as a recruiter was mildly upsetting to hear from me. Do you think with this UK semiconductor talent pool so much more competitive nowadays, do you think that approach will still work and get you the best people?
Again, things change. Back in the early 90s, things were very different. We were very different. We could do things then that we couldn't do now. I could ask questions in interviews that we can't do now. And that's, it's just different. Inviting people to come to interviews at weird times might be considered completely unacceptable nowadays. The doesn't really matter. The point I was making is it's really important to hire the right people. It is the people that make a company. And ultimately, you've got to work out whether those people you're interviewing are going to fit in and are going to pull their weight and are going to change what you're trying to do, or they're going to be difficult and need a lot of nurturing and always be hard work. And the point I was making was it's actually much better not to hire someone who is a bit dubious, if you like. You've got to be very sure. It's much easier to do without people than to hire the wrong people. And, back in those days, I think I made the point at that meeting, one of the things I was proudest about with my time at ARM was the way we recruited so many people who stayed for so long. It was a very, very effective set of recruitment. And it wasn't just about that, the business worked well and so on, but a lot of those people who I hired in the early days were still there when I left, and even some of them are still there today. And another little anecdote I'd say, actually last weekend I just had my son's wedding, and we had a whole lot of people over, some of my old colleagues and whatever. And when we were knocking down on the Monday, when my son had long since disappeared and I was left to clear up, I had a couple of my old ARM friends there, and it was quite remarkable. I hadn't seen these guys for over 10 years, and it was quite remarkable how we just knew what needed to be done. And there was very little actual talking. We just got on and did stuff because we just knew how to work together. And that was interesting to see so long after we'd all left ARM.
It's quite interesting, because a lot of what you're saying, it can almost come down to a sense of camaraderie, and if you foster that, then everything else sort of flows, like the work ethic, the communication, etc. So interesting. No, I
That's
appreciate
right.
that.
And in
Um,
those days, again, times changed. We used to spend, it's quite apocryphal, we used to spend quite a lot of time in the pub. The local pub in our village was our sort of canteen, if you like. And we never used to get blind drunk or anything, but there was quite often we'd work late, we'd pop out for a pint or two and then come back and carry on working. And so that whole sort of relaxed camaraderie side of it was very important. But it was, an adjunct to extremely hard work. And the other thing I'd say about those training events, we as a top management team, we tried to make ourselves very, very visible. We always went to those training events. It wasn't just some HR minions or whatever. We were there talking about the culture and whatever. And we used to hold lots of company meetings, town hall meetings or whatever people want to call them these days. We over communicated with our people the state of the business And we just got people involved in that way. Sorry, I see some companies today, and the top management team are quite secretive and quite, they feel they shouldn't be sharing stuff with their people. That's up to them, but I disagree. I think it's the more you share, the more you get the people feeling they're part of what we're trying to do.
For sure. I think generally people hate uncertainty, and if you provide certainty from the top, then that's going to make everyone feel a lot better. No, I appreciate that. Okay, so moving topic a little bit. Obviously, um, arms licensing approach changed the status quo in the semiconductor market. What in the market at the moment do you think looks ripe for changing? What do you think is the next big thing that's going to change the landscape? I know it's a big sort of nebulous question, but there you go.
Yeah, it's a nebulous question, so you'll get a nebulous answer. Look, I'm not clairvoyant in any of this. I think if we look at semiconductor technology at a very quite sort of techie level, Moore's law is kind of, as we've known it, has pretty much come to an end. The geometric shrinking is slowing down. Let's put it that way. It is still happening, but it's taking much longer, and the incremental benefits are smaller in that sense. And so we're moving into other technologies. I mentioned chiplets and 3D packaging. If you take the biggest chips today, the sort of the NVIDIA GPUs or whatever, we're up to chips that are now at gratical size. And a gratical, if your listeners don't know it, is the fundamental aperture of the machines that make these chips. Think of it like a 35 millimeter transparency slide. It's the size of that transparency, and you simply can't make chips that are bigger than that, single chips today, because the machines simply cannot do it. But even making chips that size is extremely difficult. The probability of getting a yielding chip is much lower than making small chips and so on. And so the industry has moved to bigger and bigger chips, and we've hit the fundamental limit now of how big you can make these chips. And so therefore, if you want to make bigger chips, you have to start putting more of them down together. And there are all sorts of new technologies, CoWoS and things like that many of your listeners will know about. And this is all a way of micro packaging die to get the equivalent of bigger chips. Not quite single monolithic CMOS, but still pretty close to getting the performance level and the pin counts that are needed. Those sort of technologies are still remarkably new and very complicated. And a lot of it has to be done in the fab because it's so close to the actual silicon. It's no longer, you can't ship it off to a packaging house anymore and so on. And there's all sorts of complexities around that. So I think we're going to see a lot more progress there. But fundamentally, what's it all for? Well, it's for doing computing, and AI is obviously the buzzword of the moment, and there's unbelievable, unprecedented investment going into AI at all levels. I kind of feel, dare I say it, I kind of feel this is probably not the right way to go. Obviously, the trajectory of AI is going to happen. It is happening and is likely to continue. But I think if you look at the DeepSeek model that caused so much hurrah or whatever last year, several things were different about that. Forget the fact that almost certainly it cost a lot more to make than they were saying and so on. That doesn't matter. The fact that they were using lower precision in those models, and therefore were able to do things much quicker. I believe that is likely and should roll out into other models and other ways of doing things. We saw the same thing with facial recognition and ML and so on. And so I think we'll see a fundamental shift within AI to different approaches. And hopefully that'll make it a bit more, smaller models will make it more efficient and hopefully lower power and therefore more practical. we're going to see more stuff done at the edge. I don't know how that's going to work, but it's going to happen. And then there are other things, in this country, one of the few things we actually do well in silicon is compound semiconductors. We actually have a significant world presence in compound semiconductors, be it all very small. I do believe some of those technologies, they are important in the sort of outer edges of the edge, if you like, interfacing with the analog world. I think we're going to see more on that. Optics is another area where I think it's maybe undervalued, underdeveloped. I think optical computing, quite a lot of quantum computing is moving into the optical domain now. I think we're going to see progress there, but I can't tell you when and how much and exactly what it's going to be.
So I sort of agree with you on what you were saying about the smaller models coming into development rather than the larger models. We're also seeing an upper limit on how much we can train these models. We've sort of run out of data to give them, and they're not scaling in the way that they were before. Do you think this will have a big impact on the semiconductor market more largely, as we don't need to be, really chasing after that last bit of compute, and we're looking more at efficiency gains? Or how do you think it's going to change the market as we transition away from kind of pure scaling models?
Very difficult to predict, but I would, and this is not just my view, it's my fundamental psyche, that doing things on big, centrally is not the way to go. You have to do it in a diverse way on the edge or whatever. And so I actually think a lot of this AI stuff we're talking about, it's so immature today compared to what it'll be in a few years' time. It's really only going to be useful once it's in your hand. It's the same metaphor or model of a mainframe in your hand, i.e. a mobile phone. Once we get to that stage, you can do so much more. And I don't know when that's going to be. I don't know how practical that's going to be, and so on. But it seems to me it's a natural succession of the way real, digital computing went. This is going to have to happen. It's got to be personal and available to you locally. And massive challenges, you can't imagine how that's going to happen, but let's assume that that's the way the market goes in the end. I mean, just take autonomous vehicles or drones or whatever. They can't be connected back to the cloud. They have to be able to make those decisions locally based on all their own local data. And so that's just a trivial example of the way I think it's going to roll out going forwards in the long term.
Okay. I mean, it's true. Obviously you have you think about all the applications in, say, supermarkets and everything that's really impactful, like you say, autonomous vehicles, and that you see all need super low latency. And so you need the sort of processors on the edge. But yeah, super interesting. Shifting topic slightly, what's the most important failure that you've had?
The most important failure?
Most important failure, yeah.
Yeah, it's one of my favorite interview questions, actually. What was your biggest cock up, or what was your biggest mistake, or whatever? And that often led to a very interesting follow-on discussion of how quickly people could think on their feet and whatever. And then someone turned around and asked me what my biggest mistake was. And I was, oh, well, we don't talk about that.
I mean,
look,
it doesn't have to be biggest mistake, but maybe
no,
something where you've learned the most.
There are a couple of things here. One in ARM days, your older listeners, may remember a thing called the dot-com bubble back in the 2000s. And ARM had just gone public at that time. ARM went public in 1998. And so perfect storm, really. We got caught up in the dot-com bubble and got swept up by it. We weren't really dot-com. We were doing something rather different, but we got swept up in that whole enthusiasm for communications and the internet and everything else. The dot-com bubble started to burst in around 2000, 2001, and we started to see that our customers, our semiconductor companies, customers, were getting into trouble, and their own results were getting poor. They weren't in trouble, but their own financial results were going the wrong way. And they were still spending money with us. And we began to think we were immune from that and that we were going to be just fine, because the argument went that we were effectively outsourced R&D, and the last thing people cut was R&D, and so we were going to be okay. 2002, it all came crashing down, and suddenly our orders stopped. And I was COO at the time, and I didn't see that, and it was really, really painful. We had a very bad day in I think it was September 2002, where the share price went from about £1.50 down to 38 pence in one day. It was horrendous. A third of the company traded its stock that day. It was quite horrendous. And that was, that was the worst time we've had in ARM, probably the biggest wake-up call. We survived, of course. We laid off a few people, but it all came back again eventually. But that not predicting that and believing our hubris that we were immune, you're never immune. And I look at the stock market prices today, some of these AI stocks, and you think, hello, I can see what's going to happen here. I don't know when, but you can see what's going to happen. And the other thing I'd say was in ARM, a couple of things. We did a big US acquisition of an adjunct company, a library cell company, and we did a lot of due diligence on that one. And every time we saw something wrong with the company, we thought, that's good, we know how to fix that. And then we'd see something else we didn't like or we thought was really not very good, and we thought, that's okay, we know how to fix that. And we ended up with this enormous list of things we needed to fix, and we went ahead and bought the company thinking we'd fix all that and it would all be glorious. It turned out very, very difficult to fix all those things. We could have fixed one or two of them maybe, but not all of them. And so that was it wasn't a disaster, but it was a very painful acquisition. And then I guess, if I look back at our time in ARM and ARM's development, I think our biggest mistake, not everyone would agree with me on this, but I think our biggest mistake was not to create an operating system and market it. We could have been Android. We could have had Android, and we didn't. And we nearly went there with the Symbian operating system. We nearly went there, but we didn't. We were too afraid to invest in something that wouldn't make money and whatever. That, I think, looking back, was probably our biggest single mistake. We could have been a very, very different company if we'd done that. But hey ho,
Yeah. I mean, you did pretty well, Tudor.
Yeah,
You did pretty
obviously things
well.
went well, but you're asking what you could have done better. I think if we'd had a bit more balls and a bit more, because
Yeah.
that was fairly fundamental, that we refused to invest in things that wouldn't make money in the short term. And clearly that was, having an operating system was not something we'd been able to monetize immediately. We didn't
Yeah.
have the vision to see what it could have been, I think.
Okay. What do you think do you think you learn to try to grab opportunity, doesn't matter how big it looks, from that moment? Or what do you think you learned from these sorts of failures?
Well, I think they're all different, right? The first example I used, the dot-com bubble, you've just got to realize that at the end of the day, gravity is quite a strong pull, and you can't defy it. And you've got to be realistic. If all your customers are failing or in trouble, it's only a matter of time till it starts hurting you. That's the first thing. The acquisition we made, I think the message I take from that was, at some point you've got to be brave enough to stick your hand up and say, are we sure we want to do this? You go down, the bankers get involved, they're encouraging you to close and everything else, and it takes a brave moment to say, back up a moment, I don't like this anymore. So that's that's a very tough lesson, but one we learned. And I'm not even saying we shouldn't have done that one, but we almost certainly paid too much for it. I think that's probably the best way to look at it. And then the issue of the no operating system. Well, sometimes you've just got to be braver and risk things. But we were very conservative. We were very hard on ourselves on what we would invest in and what we'd get a return on. And maybe that's why SoftBank looked at ARM and said, "You're not getting enough money out of this. You could monetize what you've done far better," which is why they bought us in 2016 ultimately. So yeah, sometimes you've got to do things out of your comfort zone, I guess.
Um, Again, switching topic a little bit. What do you think the impact of kind of rising trade tensions and trade barriers will be on the UK semiconductor market? I know it's super volatile right now. It's hard to predict anything that comes out of the White House or anything that will happen. But do you have any sort of broad idea of how this will all impact the UK semiconductor market?
No, I don't. It's a simple answer, but you probably want me to say a bit more than that. Look, lots of chips that we export, we tend to do more on technology and IP and that sort of stuff. And so in that sense, we're not hurt by it too much. But I don't think it's a UK issue. I think the issue is all these trade wars. They're really, really bad for the electronics and technology sector. Bifurcating Chinese technology from Western technology, I think, is a really unfortunate thing and slowing the world down. I think, the efforts, if you take AI, you can see cutting China off and forcing them to do their own thing is having interesting effects. In some ways, it's slowing things down. In other ways, it's producing different results. DeepSeek's an example of them being forced to do things differently. Huawei's Ascend chips are not as good as Nvidia's, but in some ways they're forced to do things in a more advanced way. Their optical communications are more advanced than what Nvidia is connecting their chips with. And so if you force people to do things or cut them off, they're forced to do things that you might think are not ideal, but do push forward technology. But in total, we're worse off. It would be much better if we could collaborate and move this whole thing on together.
That makes sense. Cool. So I've got one last question for you, Tudor. Now this
Uh-oh.
is the
Uh-huh. Oh, okay. So I think it's quite easy to answer that. Ever since I was doing chips, we tried to get first silicon to work, right? And Rev Zero silicon and whatever. And we got close. We didn't have to have many major respins, but most of our chips went into production at Rev 1 or not Rev Zero, but some tweak. It might have just been a metal tweak or whatever. And you sort of got away with that. These days, as chips get bigger, obviously that gets more painful and more expensive. And as chips get bigger, the probability of you missing something is bigger, and therefore you have to rely more on automation and verification and whatever. But it's simple maths, really. When a modern chipset can cost 50 million or whatever, just the mask set, you simply can't afford to get that wrong. And this can be not just a cost center, it can be an existential issue for the company if the chip they're betting on making doesn't work and you have to spin it. And so interestingly, even though we now have chips that are gratical size or reticle size and billions of transistors, people are able to get those out at rev zero in production. Not always, but sometimes. And that's all down to verification. And so I think, well, yes, verification is a bit of a pain in the ass because it slows everything down at the end. You want to get the thing out into production, but you've got to verify it properly and whatever. It is arguably the most important step. And so you can't look at it in a cost center. You must look at it as the fundamental step to releasing this thing. Because if you get your chip out at rev zero in production, you've saved yourself in reality 6 to 9 months, because that's what it takes to do a turn, if you're being honest about it. It's also millions of dollars and opportunity cost. And so, yes, all these tools might be expensive and the team might be expensive, but they are absolutely essential and arguably more important than the initial design, because it can kill companies if you just get that wrong.
Yeah, yeah. You heard it here first. Verification is more important than design, from Tudor Brown's mouth. There you go. Um, Tudor, I really appreciate you coming on. I know I threw a few curveballs your way, but I appreciate you answering them. And yeah, thank you very much.
My pleasure. Thank you for the chat.